Assalamualaikum warahmatullahi wabarakatuh. A very good day. So for part number 5, we will discuss about the property tables for superheated vapor state or superheated vapor region. Okay, so we will learn how to determine the data for the superheated vapor state or superheated vapor region. Okay, this is the TV diagram. So now our concentration is for the superheated vapor region. So this is the TV diagram in terms of temperature. So for this condition, the temperature given must be greater than T saturated at constant pressure. Okay, so the state will be within the superheated vapor region, and also we will have specific properties for the superheated vapor region. For this case, we will have specific volume for the region. Okay, so in terms of schematic diagram, this is what I call the cylinder piston device that in term of what I call in term of phase for the pure substance inside the cylinder will be 100% vapor. Okay, so when we add heat, so the temperature will increase for the vapor. Okay, also we can describe the state of superheated vapor by using a PV diagram. Okay, and then as we know, in this region the pressure given must be lower than P saturated. Okay, so if you refer to the TV, we need to look at the value of temperature, where the temperature for the region of superheated vapor will be higher than T saturated. However, if we refer to the PV diagram, we need to look at the value of pressure, where the value, if the value of pressure below than P saturated, that means the state is within the superheated vapor region. And also we will have specific, for this case for PV diagram, also we will have specific volume for the state. Okay, so in terms of a superheated vapor table, so if we look at the thermodynamic table, we can see there are tables that used to obtain the data involving superheated vapor region. For example, we have this table where this is what I call the example for superheated vapor table for water. So we will have superheated vapor table for different type of pure substance such as R134A and so on. Okay, normally for this case, for thermodynamic 1, thermodynamic 2, the table they always use during the calculation normally is the table for water and also the table for R134A, which is referred to the refrigerant. Okay, here the pressure is 0.01 megapascal, and you can see that in the bracket we have the value of specific temperature, which is 45.81 degrees Celsius. This temperature actually refer to the saturated temperature at 0.01 megapascal. Okay, so if you look at the column for the temperature, the first data state in the table is SAT. So SAT refer to the saturated temperature. So in case you doesn't know the saturated temperature, so just refer to the value of temperature in the bracket beside the value of the pressure inside this table. Okay, that represented by the red color number. Okay, so we have another example. For this case, we don't have any saturated temperature because the pressure very high, so at 60 megapascal. So we have numbers of superheated vapor table based on the pressure value. Okay, you can look in the actual thermodynamic table that you have to download from my blog. Okay, in terms of characteristic here means how we want to use the specific characteristic to determine whether the state or region is within the superheated vapor region or not. Okay, first, the temperature given, okay, at given pressure must be greater than T saturated. Okay, next, the pressure given must be less than P saturated at given temperature, and the volume of specific volume for the state must be greater than the specific volume during saturated vapor state, which is referred to the VG value at given pressure or temperature. And then also we can refer to the value of internal energy, and the internal energy value must be also must be greater than what I call internal energy value at saturated vapor state, which is referred to the value of UG at given pressure and also temperature. Okay, so the other properties is enthalpy. So the enthalpy also must be higher than Hg. Similarly goes to the value of entropy. The entropy at given state must be greater than the entropy value during saturated vapor state, which is Sg at given pressure and also temperature. So these are the characteristics that can be used to determine whether the phase or region is in superheated vapor state or in superheated vapor region. Okay, so we can use this characteristic to determine the superheated vapor phase. Example 3.6, determine the internal energy of water at 200 kilopascal and also 300 degrees Celsius. So this example actually the example for superheated vapor region problem. However, if you look at the question, so the question is general, so we do not know yet the actual phase of the state. Okay, so data given in terms of substance, the substance is water, which means we need to refer to the table involved with water. The temperature given is 300 degrees Celsius, and also the pressure given is 200 kilopascal. Temperature 300 degrees Celsius, pressure 200 kilopascal. So in terms of phase, so we need to determine the phase first before we can use this specific thermodynamic table in order to determine the specific data that required by the question. Okay, refer to the saturated water table based on pressure. So by using the pressure table, we can obtain the data directly from the table. This is the table for saturated water based on pressure table. So directly we can obtain for 200 kilopascal in terms of saturated temperature. So we have the saturated temperature equal to 120.23 degrees Celsius. Okay, so at pressure equal to 200 kilopascal, so we need to determine the T saturated by using the table. So the value of T saturated at 200 kilopascal equal to 120.23 degrees Celsius. So this is the saturated temperature value at 200 kilopascal. Okay, now compare the temperature given T equal to 300 degrees Celsius with T saturated at 200 kilopascal value. Okay, by referring to the value, we conclude that T at 300 degrees Celsius is greater than T saturated at 200 kilopascal, which is equal to 120.23 degrees Celsius. So the temperature given is greater than T saturated. So the phase will be within the superheated water vapor region or state. So if we plot on the TV diagram, so this is our we need to draw the constant pressure of P equal to 200 kilopascal, and we know that the horizontal line represents this T saturated at 120.23 degrees Celsius, where the value we obtain from the table. And now we plot the temperature given, where we just draw a horizontal line at 300 degrees Celsius and find out where the intersection point with the constant pressure line. So the intersection point will be within the saturated vapor region. So confirm the phase for the problem or for the state is within the superheated vapor region. Or we can use in order to determine what I call the phase or the region of the state, we can refer to the saturated water table based on temperature. Okay, also based on the value given, also we can obtain directly from the table. Okay, this is the saturated water table based on temperature. So at 300 we can obtain directly P saturated value. Okay, so at 300 degrees Celsius, so we can determine P saturated. Okay, so P saturated at 300 degrees Celsius equal to 8581 kilopascal. So we need to compare the pressure given P equal to 200 kilopascal with the P saturated at 300 degrees Celsius value. Okay, so now we obtain that 200 kilopascal, the temperature given of 200 kilopascal is lower than P saturated at 300 degrees Celsius. So the conclusion is the same where the state is within the superheated vapor region. So we can also obtain what we call the conclusion by using the PV diagram, where we need to draw the constant temperature line for 300 degrees Celsius. We can plot the value of P saturated at 8581 kilopascal. So the characteristic for the superheated vapor region, the pressure must be lower than P saturated. So if we draw the line, horizontal line for 200 kilopascal, we find that the intersection point with the T constant line is within the superheated vapor region. So that's how we can determine the phase by using the PV diagram, TV diagram, and also the tables. So now, in order to determine the internal energy value, so because we already know the region or the state involved is superheated water vapor, so now we need to refer to the superheated water vapor table. Also, based on the value, we can obtain directly the value of U. Okay, so this is the, so we need to find, so there are a few tables based on the pressure for the superheated vapor, okay, water table. So now based on the temperature and also pressure, at least you need to have two data. So now we have the data for pressure and also the data for the temperature. So find out the table for P equal to 200 kilopascal. So now the table, the title of the table in terms of pressure is in megapascal, so you need to change. So P equal to 200 kilopascal also equal to 0.2 megapascal. And then find out where this what I call the value of temperature at 300. So from the temperature value, so we can determine the value of U. So from the table, P equal to 200 kilopascal or 0.2 megapascal, and temperature is 300 degrees Celsius. By referring to the superheated water vapor tables, you can obtain that U equal to 2808.6 kilojoule per kg internal energy. So internal energy value U equal to 2808.6 kilojoule per kg. So we obtain from the table. So the step is, first you need to determine the phase, and then after you already confirm the phase of the state, and then you can refer specific what I call table based on the phase that you already determined. Okay, next example 3.7. So now you need to determine the temperature of water at a state of P equal to 0.5 megapascal and also H equal to 2890 kilojoule per kg. So now still we don't know exactly the phase that involved with the problem. In terms of data given, the question give you the data in terms of pressure and also the enthalpy. So we need to use this data to solve the problem in order to determine the temperature of the water. In terms of data given, first write down whatever data given. So the substance is water, pressure is 0.5 megapascal, also equal to 500 kilopascal, H enthalpy equal to 2890 kilojoule per kg. So first determine the phase of the state given. Okay, refer to the saturated water table based on pressure. So remember, in order to determine the what I call the state, the specific state condition, so you need to refer to the saturated table first. Okay, then after that, after we confirm the phase or the region, then we need to go, or we need to use the specific table based on the what I call type of region that already decide based on the phase of the pure substance. For this case is water. Okay, now the table for saturated water table based on the pressure, because the pressure already given. So look at the column for the pressure. So the unit is kilopascal. So because the pressure given is 0.5 megapascal, so you need to change into kilopascal. Okay, so 0.5 megapascal equal to 500 kilopascal. So from the table, 500 kilopascal. Okay, in terms of value that we need to obtain is the value of H, because in the question the data that suitable to compare is the value of enthalpy. So from the table we need to take our call the value of H in terms of HAF and also HG. So at P pressure equal to 500 kilopascal, the value of HF at 500 kilopascal equal to 640.23 kilojoule per kg, HFG at 500 kilopascal equal to 2108.5 kilojoule per kg, and Hg at 500 kilopascal equal to 2747.7 kilojoule per kg. Okay, now you need to compare the enthalpy value given H2890 kilojoule per kg with the value of Hg at 500 kilopascal value. Actually, we can compare both. Actually, we need to compare both Hg at 500 kilopascal and also HF at 500 kilopascal. Okay, so from the value given, if you compare, especially for the value of Hg, we can see that the value the enthalpy value given 2890 actually greater than Hg value 2747.7 kilojoule per kg. So the phase or the region that involved for the state given is the superheated water vapor. So if we plot by using TH diagram, so you cannot use the TV diagram because the diagram is we cannot plot the value of enthalpy, so you need to use TH diagram. So the shape or the characteristic of the what I call TH diagram is still the same with the TV diagram. Okay, so we have HF, Hg, so Hg equal to 2747.7, and then compare with the what I call the value of Hg given. So the value of H given, H equal to 2890. So probably so the value is higher than Hg, so you can plot. Just draw the vertical line for H2890. So the line will intersect with the constant pressure line of 0.5 megapascal, and the intersection is within the superheated vapor region. Okay, so we have two methods, whether we can use the TH diagram or we can use only the value by comparing the value of H with the Hg or HF. Okay, now we want to determine the value of T. We want to determine the temperature of the water during this superheated vapor state. Okay, so now because we already know the superheated water vapor, so we need to refer to the superheated water vapor tables. So because now because we have specific value of enthalpy, so normally we need to make interpolation. Okay, so this is the pressure, the superheated water vapor table for pressure 0.5 megapascal. Okay, so if we look at the value of H equal to 2890, so the value will be in between 2855.4 and also 2960.7 in terms of enthalpy value. So so you need to make interpolation. So because we want to determine what call the temperature, so you have to make interpolation between the enthalpy value and also the temperature value. So by using the what I call the interpolation calculation based on the gradient formula, so we have T minus 200. So now because the temperature that we will obtain is the temperature will be in between 200 and also 250. So minus 200 divided by 2890 minus 2855.4 equal to 250 minus 200 divided by 2960.7 minus 2855.4. Rearrange the equation in order to obtain the temperature value. So based on the calculation, the temperature equal to 216.43 degrees Celsius. So this is the value for the temperature for the state given in the question where the state is in superheated vapor region.